In this video, we're going to look at designed studies as opposed to just purely observed studies, observational studies. So in an observational experiment, there's really very little control over the variables at play. The researcher essentially just observes the data as it is given. In contrast, a designed experiment is one where more control exists and is one that requires a little more time, but the researcher has access to or control over some of the independent variables at play, and the hope is to learn more about a dependent variable, which is called the response. And this is typically, you would think about these kind of studies in the context of medical research. And we mentioned that there's the response variable, which is the one that we're trying to learn more about. And then we're looking at the effect of other variables called the factors on the response. So the factors are the ones that we suspect have some effect on the response. And the different levels of the factors are the possible values of the factor. So, for example, if we're talking about a medical study, then maybe a new medication is being studied for its effect on blood pressure. And so the level would be maybe, 10 milligrams, 20 milligrams dosages of the new medicine. And the treatments are really the unique factor level combinations. The reason why these are called the treatments is related to how these studies are typically done, as we will see. It's much easier to learn these things in the context of an example, so let's consider this example from our textbook. So we are told here that for several years, evidence had been accruing that indicated that folic acid, when taken by birth mothers, would decrease major birth defects. And so we see that a study was conducted by two doctors of the National Institute of Hygiene in Budapest. For the study, the doctors enrolled 4,753 women prior to conception and divided them randomly into two groups. In the first group, the women were given multivitamins containing 0.8 milligrams of folic acid. And then in the other group, they received only trace elements. So this is essentially the group that received no folic acid. And we are told that a drastic reduction in the rate of major birth defects was observed. So it would be useful to take a second and just try to identify the response, the factors, the levels, and so forth and so on. Eventually, we'll address the different parts of this study. One other term that we need to understand is what is an experimental unit. And in the study we just looked at, that would essentially refer to the women. So the experimental units are the individuals or items on which the experiment is performed. And in the context of a study where the units are humans, they're referred to as the subjects. And so some principles of experimental design essentially include the control, randomization, and replication, as you see there. So control here essentially refers to how the experimental units are divided into groups so that the treatments can be compared. Randomization refers to how the units are randomly assigned to the different groups in the study. So replication refers to having a sufficient number of units, people in the study, so that the groups resemble each other, and we can increase the chances of detecting differences among the treatments. You can see here how these three principles were incorporated into the folic acid study. One of the most common sort of experimental situations involves a treatment group and a control group. And we essentially had that in this study, the folic acid study, because the treatment group in the folic acid study would be the group of women who received the folic acid, and the control group would be the ones who did not. Now let's see each component given in this definition 1.6 from the study that we looked at earlier. So the response would be whether or not the woman's child had birth defects, so whether birth defects were present. The factor here was the folic acid, essentially, the daily dose of folic acid. And the levels, remember, the levels are the different amounts of the factor, or the different categories that constitute the factor. And so in this case, 2 dosages were administered, 0.8 milligrams to those who actually received the folic acid, and then the other group, the control group, received none. The last thing there, the treatment, remember that is the combination of the levels of the factors, and in this case, since we just had one factor, the levels and the treatment coincide. In this example, we're going to have 2 factors. So we're looking at cacti. In particular, the golden torch cactus is native to Argentina, and we can see that there were 2 researchers who investigated the optimal method for producing these cacti. They examined the effects of a hydrophilic polymer and irrigation regime on weight gain. Now, I want you to pay close attention to that sentence. In particular, the phrase, the effects of whatever on whatever. Because after the phrase, the effects of, what you see typically are the factors, and then after the word on, you see the response. And we're told here that these polymers are used as soil additives to keep the root zone moist. And so anyway, they chose to use this P4 polymer. And so we have one factor that indicates whether this polymer was used. The second factor is the irrigation, how much water was used. So we have 10 different treatments here, because remember, a treatment is any one unique combination of the factors. So one treatment would be polymer used, irrigation, medium. Let's see if we can identify all the parts here. So just take a second and think about for yourself what each one would be. So we see here the solution, the experimental units are the cacti, the response is the weight gain. The factors are the use of the polymer and the irrigation. And then the levels are given in part D, as you see there. And finally, in part E, we see information about the treatments. The treatments are summarized quite nicely in this table 1.8, as you see there. So here again, it's only when you have one factor that the levels coincide exactly with the treatments. So with one factor, the number of levels is always the same as the number of treatments, and they coincide. Here, though, we have 2 factors, and so we see the difference between the levels and the treatments. Okay, in a completely randomized design, all the experimental units are randomly allocated among the treatments. And in the example we looked at with the folic acid, that was probably a good way to do it. And similarly for the cactus study. However, that's not always the best way to do things. Sometimes we need to do blocking. In a randomized block design, we insert an intermediate step before the units are allocated among the treatment groups. Remember before we talked about control, randomization, and replication. And so this randomized block design will help us with replication. Because remember, with replication, we want the groups to resemble each other. I mean, the ideal thing would be if we could identically copy each group. But of course, that's not possible. But we do want the groups to resemble each other as much as possible. And so sometimes it is necessary to use blocking in order to do that. So let's look at an example here. Suppose we want to compare the driving distances for 5 different brands of golf balls. Here the experimental units are the golfers. The response is the driving distance. And the factor is the brand of golf ball. And the levels are the 5 brands. So we've got a 1-factor study here. So we've got to take these 40 golfers and divide them into 5 groups of equal size. We're going to do that in 2 ways. In part A, we're going to do this in a completely randomized fashion, and in part B, we're going to do this in a randomized block fashion. So for part A, it's really rather simple. We just randomly divide the 40 golfers into 5 groups of 8, and then randomly assign each of those groups to the different brands of the golf balls. So that last part is going to be done in part B as well. So let's look at part B. So the idea with part B is that because driving distance is affected by gender, then we need to account for that. And so blocking provides a better approach. So first, we're going to, we would have to assume here, or we would have to enforce that the 40 golfers are evenly divided, like 20 men and 20 women. And those are the 2 blocks, right? We put the men in one group and the women in another group, and those are the 2 blocks. And then from each block, we're going to randomly divide into 5 groups. So we're going to have 5 groups with 4 men in each group, and then also 5 groups with 4 women in each group. So we're doing this process separately as illustrated here. And then the groups in each block are randomly allocated to the different brands. And then I would modify this diagram a little bit more to then combine together to get 5 groups with each with 4 men and 4 women. And then those groups, the last step that I mentioned before, the last step is always to randomly assign the groups to the brands, the groups to the levels. So by blocking, we can isolate and remove the variation in the study that we suspect, pretty well suspect will be there. And blocking also makes it possible for us to analyze things based, per block. So we might want to just look at the men's block and what the differences in driving distances were by brand. And then similarly, we would look at the women and what the differences were in driving distances by brand.